Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatika Muhammad Saifuddin and my case number is 211292561. So this lab, I would like to present about lab 5, which is the effect of difference PID value. So basically this lab have the two we need to do, which is the procedures for 3.1 and also the task. So the procedures 3.1, this is the closed loop system. For the transfer function for this loop is the system is 1 over s square plus 3s plus 1. So this transfer function we need to do, we need to use for the MATLAB coding for doing the graph without the PID controller. We do for we need to do the coding to get the graph without PID controller and to determine the rise time, overshoot settling time, and steady state error. So I will show the coding here. So the coding, the denominator 131. We put the transfer function here into the coding, and we can get the graph respond to transfer function without PID controller. So we need to know the rise time, setting time, and overshoot. So here, rise time for this graph is 2.59 seconds and setting time 4.6 seconds. So there is no overshoot and steady state error here. So we need to put the value that we get from the graph in the table here. So in the table, rise time, overshoot, settling time, steady state error. So the second, so we done for the procedure 3.11 exactly. So next, generate system graph with and without PID controller. So the without the PID controller we already did, and we need to do the graph with the PID controller. So set the value KP, KI, and KD based on given the situation in table. Determine the rise time, overshoot setting time, and steady state error. And analyze the effect different PID based on table 3.1 and comment your answer at discussion part. So okay, for this second procedures, we need to see where there is a three condition that we need to see. First, when Kp is increased while Ki and Kd is constant. Second, Ki is increased, Kp, Kd is constant. Lastly, the Kd is increased while Kp, Ki is constant. So we need to do the first Kp, do the first PID controller, and so I just do the only one examples because the others is the same method. So uh this is the coding. Oh, sorry. So for this method I use for this value number 3, I think. Yes, Kp 15, Ki 7, Kd 3, Kp 5, Ki 7, Kd 5. So here are, so Kp 1573, 1575. So we do the example, we do the task, sorry, the condition for the third condition for procedures. So here we can see, okay, here. So this is the graph respond to Tf when Kd increase while Kp Ki is constant. KD is increased KP KI. Yes. So basically, for this is the normal transfer functions. So we need to see the rise time, overshoots. So we do the same setting time and steady. Okay, so here, sorry. So the yellow is the system number one, which is the which is KP is 15, KI 7, KD is 3. So this blue one is the graph for the PID number 2, which is the KP is 15, KI is 7, KD is 5. So the difference for both is the value of the KD. So here we can see the rise time, the rise time, I think it should be here. Alright, so here is the rise time for system PID1. So the rise time I get for this graph is 0.416 and overshot is 7.2 and settling time is 1.65 and there is no steady error. So the second is so the second system is rise time is 0.425 second. Settling time is 0.678 and there is no and overshot is 1.9 seconds. So here is the example for the condition 3. So I put the value on the tables. As we can see, the error is there is no. So the next task is alright, sorry. So the next task, we need to obtain the fast rise time, minimal overshoot, zero steady error. So for this task, we need to find the transfer function that I need to do for I need to use it for the coding and generate a system graph without PID controller and determine rise time, overshoot, settling time, and steady state error. And next, generate a graph with PID controller by using PID, P value, PI value, PD value, and PID value in table 4.1. So for the transfer function that we need to calculate, I already calculate, and I get 1 over s squared plus 10s plus 20. So this is sorry. So this is the coding that I use for this task. So this task we use the the value that I calculate from the task and I get the 1 over 1 over s squared plus 10 s plus 20. So this transformation we use for this lab. So we copy and paste here and see the graph. So this is response of transfer function without PID controller, and also we do the same peak response, setting times, rise time. So here we get the rise time 0.833 and settling time is 1.49 seconds. So we put in the table. Here, so we put in the table, overshoot, there is no value. And lastly, we need to do the PID with controller. With PID controller, we need to put all the value in the coding. So there is 4 graph in the result. So I already done the coding. So here I put here, sorry, pause. So here is the response transfer function with the ID controller. So we do the same pick response settling time, rise time, and setting rise time and steady state. If there is a steady state. So here for the first okay, so here the yellow one is the system for the number 1, and number 2 is the blue one, number 3 is red one, and 4 is the blue one, light blue. So here we need to find the rise time for PID1. So the answer is 0.0727, and the setting time is 0.772, and overshoot is 14.1%. So the blue one for the second condition is 0.00077 second for the rise time, and for the overshoot is 31.5%, and there is no setting time. So next is the red one, 0.0519. Rise time 0.40. Setting time is 0.07458. Then there is no overshoot. And lastly, the fourth condition, which is the PID controller using the PID controller. So I get the rise time and also the setting time. There is no overshoot. So the value that I get from the MATLAB, I put in the tables here. So that's all from me. Thank you.